ሄሎ ጤና ይስጥልን የማራኪ አካዳሚ ዩቲዩብ ቻናል ተከታታዮቻችን በዛሬ ፕሮግራም የወርክሺት የተወሰኑ የወርክሺት ጥያቄዎችን አብረን እናያለን። ለሚድ ፈተናችሁ ይጠቅማችኋል ብዬ ተስፋ አደርጋለሁ። So the first question, let P and Q be statements. Assume that P implies Q is a false statement. Then determine the truth value of not P implies not Q. Okay, so P implies Q is false, implies, as you know, P implies Q is false only if the hypothesis is true and the conclusion is false, right? So P is true, Q is false. Now not P implies not Q is false implies true, which is true, right? Which is true. So question number 2, translate the following composite sentences into symbolic notation. Okay, say for example the first one, either it's raining or someone left the shower on. Okay, so there are two component propositions here. One is it is raining and the other is someone left the shower on. So either or means one of the two, okay, alternatively. So the issue is it is raining or someone left the shower on. So the symbolic notation would be P or Q, where P is it is raining and Q is someone left the shower on. So simply P or Q. Okay, F, if you see this F, I will go either by bus or by taxi. So write the inverse, the converse, or the contrapositive of this statement. That is P or Q. I will go either by bus, I will go by bus is P, I will go by taxi is Q. So P or Q. So what is the inverse, the converse, and the contrapositive of this statement? As you know, inverse, converse, and contrapositive are ideas associated with the implication of a statement. So here we have, it's not an implication, it is rather disjunction, P or Q, right? P or Q. P or Q is P is not of not P, okay? Not of not P or Q. As you know, P implies Q is not P is equivalent to not P or Q, okay? Not P or Q. So not of not P or Q is equivalent to P or Q, okay? Because twice negation is equal to the proposition itself. That means not of not P, that means not P implies Q, okay? So not P implies Q. What is the inverse? Q implies not P. The converse, I mean the not P implies Q. So the inverse is P implies not Q. The converse is Q implies not P. And the contrapositive is not Q implies P, okay? So for this one, I think we need okay. So this is P or Q, okay? Where P is, I will go by bus, and Q is, I will go by taxi. Okay. So now the statement is P or Q, okay? I'll go by bus, either by bus or by taxi. But but we know that P or Q is equivalent to P or Q is equivalent to, do you have the notation here? Equal, but assume this is equivalent, not equal. Okay, this is equivalent to not of P or Q, which is again equal to negation not P implies Q. Why is that? Since P implies Q is equivalent to, okay, since P implies Q is equivalent to not P or Q. Not P or Q. Why? Because not P or Q is false. If both are false, that means P, and that is P is true, Q is false. P implies Q is false only if P is true, Q is false. Okay. So now, P or Q is equivalent to not P implies Q. So what is the converse? So thus, converse is Q implies not P. Q implies not P. Inverse. What is the inverse? P implies not Q. P implies not Q. And what is contrapositive? Contrapositive is not Q implies P. Not Q implies P. Okay. So this way, you can handle. Okay. So number 6, let's see this one. Number 6, let U be a universal set, and let P of X and Q of X be open statements on U. Then show that P of X implies Q of X is equivalent to not Q of X and P of X. Okay. So let's see this one again. So P of X implies Q of X. Okay, not Q of X. So by the properties of negation of Q of X, and P of X is not Q of X, or not P of X. So not P of X or Q of X. Not Q of X or not P of X or Q of X means by the previous statement, P implies Q. Okay, P implies Q. So number 6 is correct. Okay. Number 7, determine the truth value of these statements. So there exists X in Z, the set of integers, such that X minus X squared is equal to 1. So is there an integer satisfying this property? X minus X squared is equal to 1. So this means X into 1 minus X is equal to 1. X into 1 minus X is equal to 1, or solving this quadratic equation, minus X squared plus X minus 1 equal to 0. If you have, so when you solve this quadratic equation, if you get an integer solution, then it's true. Okay, it's true. Okay, there exists x. There is an integer which is prime and even, which is prime. And actually, 2 is an even number, which is also prime. So it exists. So it's true. For all x, an integer, if x squared is even, then x is even. Okay. Is it true for all x? For all integers, if the square is even, then the number is even. You can check that. If the square is even, then the number is even. For example, in fact, it should be true for all x's. In other words, the contrapositive is if it's not even, then x squared is not even. You can prove that it's true. If the number is not even, that means if it's odd, the square is odd. So if the square is not odd, then the number is not odd, which means it's even. Okay, even and odd are disjoint sets. So it's true. Number 3 is true. Number 4, there exists x in R. For all y in R, the product xy is equal to 1. Is equal to y. You know that xy is equal to y divided by y for y different from 0 means x equal to 1. So there exists x, a real number. Okay, so that for all y in real number, xy is equal to 1. So that x is the number 1. Okay, 1 times any number, 1 times any real number is a number itself. So there is a unique number x, which is 1, which is a multiplicative identity, satisfying this property. So the number 4 is also true. Number 5, for all x, real number, there exists corresponding y, real number, satisfying this property. For all x, there exists 1. So that means y is equal to 1 over x. Okay, y is equal to 1 over x. But this is not true for x equal to 0. If x is 0, say, because 0 is a real number, this thing does not work. You cannot find y, a real number, which is 1 over 0. So number 5 is false. Okay, number 5 is false. Okay. Some of the questions are supposed to be problems for the assignment, so I just move to the other questions. If A is equal to this, then describe the power set of A. Okay, so the power set of A is a set of all subsets of A, including the empty set and A itself. So this set has 1, 2, 3, 4 elements, -1, -1 in bracket, 0 and 1. So the power set would have how many elements, or A would have how many subsets? 2 power n, which is 2 power 4, 16. So the power set of A would have 16 elements, which are subsets of A, including the empty set and A itself. So you can list all subsets. You can put the singleton sets, you can put sets containing 2 elements, you can put sets containing 3 elements, and finally A itself. Okay, number 13. Let A be any set, and the power set of A be the, okay, P of A be the power set of A. Explain why each of the following is true. The empty, the A itself is an element of the power set of A. That's true. The power set of A always contains the empty set, the null set, and the set itself. Okay, because a set is a subset of itself. Okay, so it's true. B, the empty set is an element of the power set of A. Yes, the empty set belongs to the power set, so it's an element. Every member of the power set is an element of the power set of A. C, the empty set is a subset of the power set of A. Yes, it's true. Why? Because the empty set, it is an element. At the same time, empty set is a subset of any set. Okay, so empty set is a subset of the power set of A. That's also true. And D, A is a subset of the empty set if and only if A is equal to empty set. So A is a subset of the empty set. Okay. As you know, the empty set contains no element. So the empty set can only contain itself. Okay. The empty set cannot contain any other element. So if A is a subset of A, empty set, then A is empty set itself. So that's true. This is an if and only if statement. That's true. Okay. Okay, so I have tried to show you some of the questions in the worksheet. I just tried to give you a brief idea. So you have to take note and practice explaining or justifying some of these questions. Thank you very much. That's enough for today. Bye-bye.